Welcome to Inquisitive Kids. My name is Karen, and in this lesson, we will be looking at the mixed operations of fractional expressions. This is part 2 to our lesson, Adding and Subtracting Fractional Expressions. Learning goals. Review and consolidate the operation rules of fractions. Perform mixed operations of fractional expressions proficiently. So for our introduction, we're going to be doing some review. What are the multiplication and division rules for fractional expressions expressed in variables? And what are the rules for addition and subtraction of fractional expressions expressed in variables? Well, for the first one, it would be b over a times d over c is equal to bd over ac. And that b over a divided by d over c is the same as b over a times the reciprocal of the divisor, which is the second fraction, so times c over d, which is equal to bc over ad. So for division, we're just turning it into multiplication first. Using the 3 steps, keep the first fraction, switch the operation, and flip the second fraction into its reciprocal. For the next one, it would be b over a plus or minus d over c is the same thing as first you must make sure that they are like fractions. So you give them common denominators and then you add or subtract the numerators while keeping the denominator the same. So in this lesson, we're going to be putting together all of these operations to solve some mixed operations. Adding and subtracting unlike fractional expressions. Calculate this problem right here. We can see that the denominators are different. So first we have to turn them into the same denominator. The original equation would be equal to 2 over x minus 1 plus x plus 1 over x minus 1. So as you can see, the operation changed from subtraction to addition, but our denominator also changed. It was multiplied by -1. So notice how 1 minus x is the same thing as -1 times x minus 1. So simplifying this, we get 3 plus x over x minus 1. Now here is the second problem. Pause the video and solve. Well, for this one, we can first find the LCM, least common multiple, of the denominators, and then we can find the equivalent like fractional expressions to add. This is how we would cross multiply to get common denominators, and then we would add. This would give us 4p over 4p squared minus 9q squared. Now here is a third problem. Again, we're just doing lots of review, so pause the video and solve. You'll notice that in this problem, we are handling polynomials, which means that we need to factor them first. In order to factorize, we can remove common denominators and we can use the perfect square formula. And then after we get common denominators, we can subtract and then we'll have x minus 4 over x times x minus 2 squared. Knowledge key point. Adding and subtracting fractional expressions. First, we add and subtract unlike fractions. Then, by finding the least common multiple of the denominators, we have like fractions. And then after keeping the denominator while adding or subtracting the numerators, we have our final answer. Example 2. Calculate a squared over a minus 1 minus a minus 1. Here is the solution. We can think of a whole expression as a fraction with a denominator of 1. So even though it doesn't look like it's a fractional expression, you can just give it a 1 at the bottom. So it would be the same as this expression. Now using the steps that we've just talked about, we have 1 over a minus 1 as our final answer. So pause the video and check your answer. Did you get that one right? And if you didn't, where did you get it wrong? Comment down in the comments down below. Now here is method 2 to doing this problem. Again, we get 1 over a minus 1. Example 3. Calculate 2m over m squared minus n minus 1 over m plus 3. And I want you to give m the value of 1, -3, or 3, and substitute to see what would be the value of this expression. Well, I'm just going to first simplify. Whenever we are doing problems like this, we always want to simplify the expression first before substitution. So we can first factor the denominator of the first fraction, and then after subtracting, we have 1 over m minus 3. I'm choosing to give m the value of 1. So if m is equal to 1, then the original equation is equal to 1 over 1 minus 3, which is equal to -1/2. But again, if you chose to give m the value of -3, you would have gotten -1/6. And if you gave it the value of +3, that would be 1 over 0. And that's not something that exists in mathematics, so the answer would not exist. There would not be a possible answer. Exercise. First simplify, then substitute. 1 over x minus 1 minus 2 over x squared minus 1. Among them, x is equal to -2. We're just going to do this problem together. So here is the solution. We first factor the denominator of the second fraction. And then, after cross-multiplying, we have 1 over x plus 1. Now substituting -2 as x, we have -1 as our final answer. Now we're moving on to the mixed operations of fractional expressions. How would you calculate 2a over b squared times 1 over a minus b minus a over b divided by b over 4? As you can see, in this expression we have exponents, and we have subtraction, and we have multiplication and division. Please think about the operations involved in this question first, and then determine the order of operations that you would solve them in, and then try to solve it independently. Pause the video and try it on your own first. Here would be the solution. We need to follow the steps of order of operations, just like PEMDAS: parentheses, exponents, multiplication and division, addition and subtraction. So let's say we do the multiplication and division first. Well, let's say we do the exponents first. The first term would be simplified to 4a squared over b squared. And here, we can turn division into multiplication by keeping the first fraction, switching the operation, and flipping the second fraction. And now, we can multiply each of these groups, and in the end, we would have 4a over ab minus b squared. Key point summary. Order of operations when solving fractional expressions. We always first do the exponents, then multiply and divide, and then finally add and subtract. But if there are parentheses, we first solve the parentheses. So if you have multiplication outside of parentheses and inside the parentheses you had add addition or subtraction, you would still do the addition or subtraction inside the parentheses first. And again, the final answer must be simplified. So any answer you give must be in simplest form. Example 4. Calculate this expression. All we have to do is take it slow and follow the order of operations. Original equation is equal to m plus 2 times 2 minus m plus 5 over 2 minus m times 2m minus 4 over 3 minus m. We can do the addition inside the brackets first and then the multiplication outside the brackets. So that would give us this expression. And then after factoring the numerators and multiplying, we have -2m minus 6. So when a whole expression appears, we can look at it as a fraction with a denominator of 1. Now here is our second problem. We always first do whatever is inside the parentheses. We can first factor the denominators of the first and second fractions. And then after subtracting, we have 1 over x minus 2 squared. Notice that when the numerator or denominator is a polynomial, it must be factored first. If it can't be, then we can view it as a whole. Practice. Calculate this expression. We see that we can actually apply some formulas in here. So on the bottom of the first fraction, we can use the perfect square formula and turn it into m plus 1 squared. And this is divided by m plus 1 over m plus 1 minus 1 over m plus 1. Do you see what we did here? Instead of writing 1, we turned it into m plus 1 over m plus 1, so that when we subtract, we would have like fractions. So this is something that you need to get used to in math, because sometimes making a number a bit more complicated might actually result in the operation being simpler. So by turning a 1 into something a little bit more complicated, it makes it easier for us to subtract. So our final answer would be m over m plus 1. Example 5. Calculate this expression. Here's the solution. The original equation would equal 1 over x minus 2 minus m 1 over x plus 2 times x plus 2 times x minus 2 over x. Now we can factor out the common factor of 1 over x plus 2, and we have 4 over x. We can simplify using the distributive property and factoring out common factors. So here is our method summary. Observing the structural characteristics of the question, we can use formulas flexibly and using calculation skills appropriately. And this can make solving the problem easier with accuracy and speed. So sometimes you don't need to do the order of operations step by step. By applying formulas, then you can sort of skip over some of the steps, almost like a shortcut, and it makes your calculation much faster and much more accurate. There are two ways to solve this expression, and here the box just means multiplication. So, can you try to find the two methods that you can solve this with? The first solution is according to the order of operations. So this would be the steps here, and we would have 2x plus 8. As you can see, we're just following, the parentheses, the multiplication, division, and then addition and subtraction. We're just following it step by step. But the other way is to use the distributive property of multiplication. We can factor out the common factor, and we still have 2x plus 8. Example 6. Calculate this expression. Here's our analysis. We can think of 1 over a plus b and 1 over a minus b each as a whole. So even if this makes it easier, you can always replace a plus b as x and a minus b as y. So if you just replace it with single variables, it makes your calculation much easier to look at. So by thinking of a plus b and a minus b each as a whole, you can just apply the formula, and then in the end, you'll have 2a over a squared minus b squared. Now let's do some step-up training. So this is a bit more challenging practice. Example 7. Simplify this complex fraction. And as you can see, this is complex because its numerator is a fraction of its own, and so is its denominator. Here's the first method you can solve this with. The original equation is equal to 1 minus 1 over 1 plus a divided by 1 plus 1 minus a minus 1. So what we did here was, instead of putting it in fraction form, we turned it into the division between two fractional expressions. So when we can write the complex fractions in the form of dividing the numerator by the denominator. And then now we can just apply the division rule of fractional expressions. Our final answer would be a minus 1 over a plus 1. But here is our second method. We can just put it in the form of the numerator divided by over the denominator. So for some people this is a bit more complex, but for others this can just actually be more helpful. So now, as you can see, we are taking out the common factors, and then we are simplifying this fraction. In the end, we'll have a minus 1 over a plus 1. Example 8. If 2 over x squared minus 1 is equal to a over x minus 1 plus b over x plus 1, find the value of the variables a and b. Here's our analysis. First, we can convert both sides of the equation into like fractional expressions, and then we can compare the numerators on both sides to get the system of equations with a and b as the variables. So our first step is to make all three of these fractions like fractions. So by giving them each a denominator of x squared minus 1, we have the system of equations a plus b is equal to 0 and a minus b is equal to 2. Solved, a is equal to 1 and b is equal to negative 1. Out of these problems, here is the conclusion. Mixed operations of fractional expressions. We need to follow the order of operations, which is parentheses, exponents, multiplication and division, addition and subtraction. So not that different from calculating numbers. The mixed operations of fractions generally follows the conventional operation sequence, but sometimes you need to apply special multiplication formulas and properties. That way you can make your calculation faster and more accurate. Here are the features of the operations of fractional expressions. It's combining the use of operations of whole expressions, factorization to simplify the fractions, and fractional operations. All of these mixed together. Class summary. Today we learned the different methods for addition and subtraction of fractional expressions. We first add and subtract unlike fractions, but by finding the LCM, we turn it into adding and subtracting like fractions. We keep the denominator and then we add and subtract the numerators. And then we have our final answer. We also learned how to conduct mixed operations of fractional expressions. Parentheses, exponents, multiplication and division, addition and subtraction, the basic order of operations. Again, these are the two skills that we learned today. Review and consolidate the operation rules of fractional expressions. Perform mixed operations of fractions proficiently. Thank you so much for watching through Inquisitive Kids, and I look forward to seeing you next time.